Okay, in this video we want to examine what we call equations in irrational forms. Now, another name for this, when you hear equations in irrational forms, another name is what we call radical equations. Another name is what we call radical equations. And what do we consider here? What we consider is equations in a single variable. Equations in a single variable and in irrational forms. So we consider equations in a single variable and in irrational forms. What are the keywords there? The keywords there are this: the word single variable and the word irrational forms. These are the two keywords we're going to be looking at. And as I said earlier, that equations in this form are also known as radical equations. For example, if I have 2 roots 3x plus 4 plus x is equals to 36, this is an example of radical equation. This is an example of what we call radical equation. Now, the expression inside the square root, is what we refer to as the radicand. Please note that that's a very key word there. Not just any expression, but the expression inside the square root is what we refer to as a radicand. Now, quickly, let me deviate a bit. There is this formula you are familiar with, which we call the quadratic formula. Now, this expression b squared minus 4ac is called radicand. So any expression inside the root is what we refer to as the radicand. Now, let's try to solve this example above, and let's see how we solve radical equations. Very easy, and I want you to please follow me as I take it one step at a time. Now we have 2 roots 3x plus 4 plus x is equals to 36. Now the first thing I'm going to do is to move this x, and that gives me 2 roots 3x plus 4 equals 36 minus x. Now, two things are involved. You can decide to square both sides. Square both sides. Now, if I square both sides, that means I will have 2 roots 3x plus 4 equals 36 minus x all squared. Now, you need to be careful if you're using this approach. Don't say square cancel square roots, because there's still a 2 here. Just like when you have 2x all squared, you can't say the answer is 2x squared. You would rather say it is what? 4x squared. So in this case, this would give us 4 into brackets 3x plus 4 equals 36 minus x all squared. So let's open up our brackets. We'll have 12x plus 16 equals 1296 minus 72x plus x squared. If you expand this, this is what you're going to have. Then we rearrange. So we have x squared minus 72x minus 12x plus 1296 minus 16 is equals to 0, which will result to x squared minus 84x plus 1280 is equal to 0. So at this junction, you can use the factorization method, you can use the quadratic formula. But most times when you have it with high numbers like this, it is advisable to use the quadratic formula, because so that you don't waste so much time thinking of the two numbers. So if I'm using the quadratic formula, my a is the coefficient of x squared, which is 1. My b is the coefficient of x, which is negative 84. My c is the constant, which is 1280. And the formula says negative b plus or minus the square root of b squared minus 4ac divided by 2a. And doing that would give us minus b is now negative 84 plus or minus negative 84 squared will definitely give you a positive result, which is 7056 minus 4 times a is 1 and c is 1280, all divided by 2a, which is 2 times 1. So that gives you 84 plus or minus, now 4 times 1280 would give 5120. So subtract that from 7056, you have 1936 over 2. So don't forget it is plus or minus. So you have 84 plus root 1936 over 2, or 84 minus root 1936 over 2. So let's take each one of them, and that would give you definitely the first result will give you 64, and the second result would give 20. Now at this point, the two answers may necessarily not be equal. So what you do most times is you check for you to know, will you have the two solutions to be the answer to the question, or there will just be only one of it that will be the answer to the question. And that is the essence of you checking. So if I use 64, I'll have 2 roots. 3 times 64 is 192. 192 plus 4 is 196 plus 64. And square root of 196 is 16. Sorry, 14. 2 times 14 is 28 plus 64, which is 92, which is not correct. So this is not solution. Now let's try 20. 3 times 20 is 60. 60 plus 4 is 64 plus another 20. Square root of 64 is 8. 2 times 8 is 16 plus 20, which is 36. So that tells you that your x will be what? 20. So the solution to this radical equation will be 20 and not 64. So you can see the process. It's just like your normal algebra you do, but you just need to be careful when you're trying to attempt questions like this. All right, I hope this video and this example helps a lot. Okay, I'll try and solve one more, then we'll be fine. Okay, so I have a question that says 2 then root 3x plus, oh sorry, it's the wrong question. When you have a question like this, square root of x plus 8 plus the square root of x plus 1 is equal to 7. In this case, there's nothing to move. Rather, you square both sides. Okay, so can I say this? Can you pause the video, try to attempt this question, and after you're done or you're stuck, you can play and see where you have gone wrong or if you actually correct. So what I will try to do is to square both sides. And that will give me 7 squared. Now, in squaring this, you need to really be very careful. X plus 8 plus x plus 1, another root x plus 8 plus root x plus 1. So root x plus 8 times root x plus 8 will give us root x plus 8 all squared. Root x plus 8 times root x plus 1 will give us the square root of x plus 8 and x plus 1. Root x plus 1 times root x plus 8 will give us root x plus 1, x plus 8. Square root of x plus 1 times square root of x plus 1 will give us square root of x plus 1 squared. Now square cancels out square roots and we'll have what? X plus 8. This plus this, they are like terms, so you can say 2 roots x plus 8 x plus 1 plus square can also cancel out the square root and you say x plus 1 equals 49. So adding x plus 8 to x plus 1 will give us 2x plus 9 plus 2 roots x plus 8 x plus 1 is equal to 49. Because we're trying to solve for the roots, we can try to take 2x plus 9 to the other side so that we can have 2 then square root of x plus 8 x plus 1 equals 49 minus 9 minus 2x, and that gives us 2 square root of x plus 8 x plus 1 equals 40 minus 2x, which takes us to how the first example we did above looks like. Now from here you can decide to square both sides. Also you can decide to divide both sides by 2, because I know that if I divide both sides by 2, the 2 will easily go in 40 and 2. So you just do that to make it easier. Divide by 2, divide by 2. So 2 will cancel out 2, and that will give you x plus 8 and x plus 1, which is equal to 20 minus x. So from here, I can decide to now square both sides again so that the square can cancel the square roots, and I can have x plus 8 x plus 1 is equal to 20 minus x all squared. So at this point, if I expand the left hand side, I will have x squared plus 9x plus 8. And if I expand the right hand side, I will have 400 minus 40x plus x squared. So next thing we do is to try to collect like terms. So we'll have x squared minus x squared plus 9x plus 40x plus 8 minus 400 is equals to 0. X squared minus x squared minus x squared will give us 0. So 9x plus 40x will give us 49x. 8 minus 400 will give us minus 392 equals to 0. So this means we'll have 49x is equals to 392 divided by 49 divided by 49, and our x will give us about 8. Just to double check, 8. Now looking at the question from the beginning, it looks like, oh, this is going to be very long, very difficult, but it looks easy. if you follow the steps very well. But where the most sensitive part of this question is when you're trying to expand out this. This is where it is really, really very, very sensitive. So if you put 8 back into the original question, you should definitely get 7. So let's try. 8 plus 8 is 64. The square root of 64 is 8. 8 plus 1, oh sorry, 8 plus 8 is 16. The square root of 16 is 4. 8 plus 1 is 9. The square root of 9 is 3. 4 plus 3 will give you 7. And that is how you solve questions as it relates to solving radical equations. I hope this video helped you to understand equations in irrational form and radical equations. Thank you.